Hello, everyone. Thanks for coming. I know it's the end of the day, so you might be a little bit tired. So today we're going to speak about optimizing mobile web applications. Let me tell you a little bit about ourselves. We are software developers from Ukraine. I'm a head of MobiDev, and Yurii is the head of HTML JavaScript development at MobiDev. So we have only one microphone, so we'll try to share it. And yeah, so actually we're going to speak about a very important problem in HTML development. Like HTML has a lot of great advantages, and like a couple of years ago when we just started working with it, and we faced the issue of performance. And we faced it on both mobile websites, responsive websites, and on our HTML, JavaScript cross-platform applications, which are packed in PhoneGap Cordoba. Yeah. And basically, we've explored a lots of frameworks, and they didn't give us straight answer, and there is no documentation. So why is it so? So there are only pieces of information which you can find in the internet, and which can help you in optimizing your mobile applications. So we tried just to pack all our experience and present it to you. And actually, on this conference, it has been several very good topics about pretty much the same. What we are going to say additionally is not only why you should use, why these solutions which we are going to speak about are good, but also we are going to tell why is it so. So we are going to talk about how browser internals work. And yeah, so four main things which we're going to talk about today is file loading on mobile devices. It's rendered tree optimizations, such operations as Reflow and repaint, very consuming. And it's document object model optimization, and solving such problems as excessive DOM, custom events, DOM manipulations. And we are going to speak about JavaScript optimization. And at the end, we will show you a video of how optimized app works. Okay, Yurii?
Yeah. When you read some recommendation on optimization of JavaScript HTML application on mobile devices, the main attention is paid to optimization of interaction between DOM, document object model tree, and JavaScript. But why does work with DOM from JavaScript leads to lag? And how can we deal with them? The answer to this question cannot be found without understanding inner mechanism in the browser, inner process, and we shall cover them, talking about main flow in the browser engine. And as example, we will talk about WebKit main flow. Yeah, of course. So, as you see, WebKit main flow contains three main stages: loading, reflow, and repaint. And each stage have several inner stages. And for example, loading consists HTML loading, style sheets loading, and HTML parser, uh, CSS parser, and repaint contains painting and displaying your content of application. But the main difficult part of WebKit main flow it's Reflow. It it contains a document object model tree, apply mechanism for applying style rules to the document object model. Uh, it's pink rectangle name attachment, yeah, and also contain layouting and render tree, and we start from network from loading uh, in mobile application. The main thing to know here, as a rule, uh, data transmission goes through slow cellular networks, and parsing your data takes more time than on desktops, owing to lower processor performance on mobile devices, uh, as well as optimization uh, mobile device manufacturer. And also you should know data is transmitted by packages because package size have around 1 kilobytes. There, mm, it's and if you lost some packages between transmission, you should be uh, um, required it. So it led to slow down your network API.
I just wanted to add, we did so by optimization on different devices. Um, it's meant that, for example, HTC and previously Samsung,
Yeah.
they like stated that browser process should have low priority. So processor might like put not so big attention to your process, and so data can load slower. That's the case for Android.
Yeah. At what is the specificity of mobile transmitter, hardware transmitter, and 3G uh, cellular system? The first uh, transmitter in mobile system consumes lots of energy, and it plays second place after device screen. It have three main conditions, three main stage. DCH, it's when full power, and uh, when you transmit some data. Second, it's when transmitter have half power, named it fetch. It's when transmitter waiting of uh, data and idle. And transmission between idle and DCH and approximately takes around 2 seconds. It's it's led to better drain because if you see on this chart, after your network query API uh, 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 transmit to the idle takes around 2 seconds. And what is approach to avoid the better drain? The first, send bigger volumes less often. It's optimization of your network API. The second, use k-events for your application. It's functional optimization. You can use, for example, some events of your optimization, uh, page transition, of page changing on unload event, or application didn't enter background. And I think it's most important, it's research of better drain by AT&T company. You can see link on this research on the slide. And the next and last, use asynchronous loading wisely. Uh, for example, if you have single page architecture on your application, as rule, you have one big JS file, one big file with CSS rules, and also you have huge HTML. But you have divide, for example, your JavaScript file to the 5 or 6 large parts, and you have and you should load it asynchronous, but then you should load only one launcher file with only one row code. So it depends on architecture of your application. And done.
Let's have a look at the visual processing part of the picture which we reviewed previously. Yeah, so here it is. It contains parsing HTML and CSS, rendered tree construction, and layouting of the render tree and painting the render tree. And basically, the most heavyweight operations here are reflow and repaint. Reflow is recalculation of your layers in the application, so it's like placing the elements on their positions. And yeah, so it's composing layers, and then the picture which was formed is going to be drawn on the screen. And these are really time-consuming operations, and we should pay special attention to them. Let me illustrate my statement with this example. So it's a screenshot of Chrome developers tool, and you might see this if you open a website. And you can see here yellow, it's JavaScript execution. Purple, it's reflow, like composing layers, which I mentioned. And green is repaint. Also, please pay special attention to the transparent part, which is quite big. It says it's idle, but like there are some internal processes in the browser, like garbage collection, which is happening there, and much harder to optimize. Also, please pay attention to the frame per second ruler. Fast application should have at least 60 frames per second, and this example might and probably would lag, and user will see it. So, and what is the reason of calling reflow? It could happen in when you access or try to change parameters within your elements or for the whole window. So this is a list, probably it's not full, of the operation which call reflow. And it might be a good idea to print out this list and put it as a reference. And at the same time, it's better to understand why this is happening and what's going on internally. So there are like two large types of reflow. One is global, which is synchronous, which means that the whole app, the whole window will be yeah, so will be reflowed. And it happens when, for example, font change or Windows size change, and that's very heavyweight and very rare, rather rare. And in all other cases, it's incremental layout, which are Asynchronous means that depending on the browser implementation, these operations are either put in the queue or in a cache, and when main thread is main flow is free, it will process it, these operations. So for this reason, for example, in the book by Nicolas Zakas, High Performance JavaScript, it's advised to group operations which cause reflow in one place of programming code instead of having it everywhere. And how does incremental reflow happen? The system of dirty bits is used inside. It's like when an element needs reflow, it will be marked as dirty, and its children will be marked as dirty. So, this happens in. So, what's happened after that is the following 4 stages. The parent renderer determines its own width. It will go over each of the children, will place each children of the children to its location, sets its y and x, and it will call child layout if needed. And after that, we will have the child's height, which will be accumulated, and margins and parents will be added. So like the element will know its height, and it will be used also for the parent renderer. And the dirty bit sets to false. So I'd like to note that when the element is in separate flow, for example, if for this element, if you set position absolute or position fixed to this element, this element will be reflowed in a separate flow. And in this case, only this element will be recalculated, and the rest of the page will remain the same. And that's actually a very good idea to use position absolute or position fixed for this case to optimize parts of your screens. And another bad example is float left, float right, which will cause recalculating the main flow first. So all the elements on the screen will be recalculated, and then render will return to this specific element. So better to avoid float left and float right. Let's have a look at another example. And basically that's a screenshot of scrolling animation of the page of our demo application, which we'll show you, with an infinite list with over 10,000 elements with different text and images. The static content elements such as header and footer are also there. And you can see that it uses correct layouting, which means that it uses correct division into layers, and which are separately recalculated. And general time of these recalculations are much slower and allow to have very smooth animation. And it's actually 62 frame FPS, which is less than frame budget. Agree?
Yeah. And the second part of our discussion is painting. Some familiar with it, but the most as rule in this case, the main thing is used to GPU animation, GPU acceleration for mobile devices. And on the slide you can see typical approaches of shifting the element to rendering the GPU. As rule, the first two are used, but sorry, efficiently and implementation of this shifting depends on browser engine. For example, second approach, it's transform translate 3D, don't work in EOS 6. I think it's bug, but it's true. But we have some problems with GPU acceleration because in CPU we operate with DOM object, DOM elements. In GPU we operate with textures, and transform between CPU and GPU takes a time. The same transition to GPU of your elements always a separate repaint, and by this reason memory consumption grow, because in your application in the same time you have DOM structure and GPU textures, and the most important, if you by incident partially place a layer that not shifted to GPU under layer which shifted to GPU, between your animation the first layer will be placed to GPU and back. It's led to lags for mobile users. So the last and more important, you can't accelerate everything, because the first reason memory consumption grow. The second reason it can be led to lags for users. Sorry. And what about approaches to GPU animation? The first, animate elements with position absolute or fixed, because it's already separate layers. Use GPU animation. Transfer animate layers to GPU before have your animation, and try to use CSS transition with light request animation frame if you need some huge widget with user interaction. In the next slide you can see example from Mario Spinelli, author of iScroll. It's like light request animation frame, it's light ref, and the gist of this example, it's when you have some interaction from user, you don't change element attributes. You should change element attributes only after request animation frame loop started, because in this approach you will have light animation, you will have more powerful animation. And a little about image scaling. The first and main idea is please don't scale image, because we have some examples of it. For example, we have EOS application which one image 500 pixels wide width, and we try to scale down 1.3 times, and this scaling during more than 10 milliseconds. It's more than half frame budget. It's unacceptable for mobile users. So if you have some tasks with scaling scale images, you should replace uh, uh, this scaling to the server side, or you can use some approaches, some different approaches. For example, you can use canvas with image and scaling of the in of them of DOM canvas. So, but basically, please don't scale image. And yeah.
So the next thing, which is very important, is document object model. And our suggestion, or please do a favor, don't make your DOM too overloaded. So please keep your DOM document object model very lightweight. The reason is that because the bigger number of elements there are in your DOM, the more time it will take to query an element. It's and to manipulate with it. That's why we will discuss these issues of excessive DOM manipulations and custom events. So on the next slide, you might see an example of how much time it will take to query an element of DOM. And if you have like 3 elements in your document object model, you will not notice that time. It's nothing. But if there are like 10,000 elements, which is pretty average for an app of 10 screens, and then you will notice it. It's already 0.36 milliseconds. Plus, additional libraries will also add time, so your application might lag. Of course, this is like synthetic tests, but the numbers are pretty explanatory. And so what could we do with that? First thing is we could query an element once, then store it for the further usage, not query for it again. It's a good idea, and this is a part of solution. Another part is to have less elements in your document object model, and to keep only those elements which are visible to a user. So it's like a screen of your app, and it should be in the DOM. How it can be done? It's actually pretty easy. You can define attach and detach functions, which will actually show and hide your screens in your mobile app, mobile web application. And so you can see it on the code. And the beauty of this example is that in JavaScript, in your variables, you have pointers to these DOM branches. So when you detach a branch, you will still have a pointer, and the garbage collector will not free this memory. So this saves time a lot when switching between screens. And yeah, when you don't need it, you can avoid having the variable. And there are 2 approaches of implementing this. So first, you will have an empty element, and you will fill it with HTML elements with content, and you will attach it to the DOM. Or if you have a large single-page application which you downloaded once, you can just detach those pages which are not seen at the moment and show only one. So first approach is on the left, second is on the right. And that's why during manipulation with DOM, with document object model, we use the following approach. We cache everything, so we reuse document object model structures to avoid allocation, deallocation. And we detach DOM branches, and we use different programming patterns such as flyweight, pool, adapter, etc.
Yeah, and little about custom DOM events. The custom DOM events, it's very heavy object for browser because they have a relation between DOM and JavaScript in the same. And the second reason, it's pipe between DOM and JavaScript virtual machine. It's very small. So if you try to use custom DOM events, for example, you have the same on several frameworks for touch devices. This it's led to lags because it's pushed this object and bring a garbage collector to working. So try do not use it often, and if you really need it, try to use object pool and for example pops up architecture in your application for avoid a relationship your custom events with DOM. And what is exactly garbage collector? Because it's very important for development on JavaScript. The garbage you should know. There is no manual memory management in JavaScript. It's managed with garbage collector, and garbage collector works in main flow on your browser, and one needs several JavaScript garbage collector loops for memory emptying. And what exactly garbage we mean? You can see several examples on the slide. For example, red column is when your code creates some garbage, and green code not create garbage. And in the top you can see function which return some object created by literals, and exactly this object is garbage. And when this object already done used, garbage collector should be collect them. And second example, it's for a very popular function from JavaScript. It's for each function, and in this case we have garbage because we in every iteration of this function we create an anonymous function. Yeah, sorry. And in the green column we don't have any garbage, because in the first case we use temporary object for returning some results from our function, and in the last example we have iteration by index of array. So what? Yeah.
So the main idea here is reusing the variables which you have once put in. So, and of course it's a little bit against the best coding practices, and we should understand that best coding practices and optimization is like two sides of one.
Yeah,
so
it's refactoring and optimization. It's opposite.
Yeah, so you should select, but maybe this example on the right doesn't look too ugly.
Yeah. On the next slide, you can see example of object pool. We use it this code for transmit a huge number of the same type of object between JavaScript models. For example, we use it for transmit our shifting value from a gesture adapter and infinity list, and yeah, it's simple example. And let's take a summary. Simplify your DOM document object model, manipulate with DOM tree, understand the markup layers, use position absolute, use position fixed, and use compose layers with translate 3D, and try to simplify your CSS. Try to don't use shadows, gradients, half transparent, because it's a very consuming, very huge operation for mobile processing. And try to use hardware acceleration for your CSS animation, and cache everything, and try to monitor the work of garbage collector. For example, we don't have tools for mobile for monitor the work of garbage collector on mobile devices, but we have some hardware flags for launch Chrome, and we can create JavaScript HTML application in the browser. And also, when we already have memory efficiently application, we can pack it by PhoneGap, for example. And yeah, and
Yeah, so let's have a look at the demo.
Yeah, it's
right. All right.
Sorry, it's home video.
Okay, so that's our art project. It's a demo application which was made just in 2 weeks using a Node.js framework, and it's actually quite heavy loaded with graphical and text content. And as you can see, it's pretty smooth. The list can have any number of elements, and this works in the same way on different platforms like iOS, Android. So yeah.
It's code without native parts. It's pure HTML.
Yeah, so it's pure HTML.
Yeah. We use framework which based on backbone JS, but now we start with on the second version of our framework. Consists independent widgets, and you can use this widget with any frameworks. For example, you can use Infinity List with AngularJS, AmberJS. It's not a problem because it's pure independent parts. So yeah, some videos. So if you have some question, we would like to answer.
Yeah, we would like to ask you for your feedback and for your questions.
Yeah.
Can you repeat the name of the framework? Is this a
Oh, sure.
framework?
It's
RAP.js, RAP.js. It's Rapid Application Development JavaScript. It's by license. We have
So this is a framework.
Oh, it's sorry.
Yeah.
for
What?
internet. Yeah, a part of this page it's by Node.js, and you can see on GitHub. It's sorry, we don't have Wi-Fi, but yeah, but it's first version and second version we start named by as Node.js tools, and we already have field service locator, scroll view, scroll bar pops up, it's button, list view, it's infinity list.
Yeah. So it's actually pretty good that you can use it with any other framework, like with Angular, if you like, or Backbone.
Yeah, it's independent part of our framework.
Yes. Thank you for your question. Maybe you have other questions. All right. So thanks a lot for your attention, and I wish you to have a great evening. Thank you.